An industry expert on AI for automated inspection and quality control. AI has been a very hot topic, not just nationally, regionally, globally. So I would like to invite Chris Bowman, President of Canada.
Not of Canada, just Sesotec.
Sesotec.
Just wanted to make sure we haven't had an election yet.
Please welcome Chris to the floor, to the stage. Thank you.
All right, joining me is going to be a colleague of mine from Germany, Herman Samerr. So he's actually the real expert. So that was a pretty big claim that was just made, that I'm an expert. Awesome. All right, so a quick introduction. My name is Chris Bowman. I'm with Sesotec Canada, Metal Detectors and X-rays. I'm going to give you an X-ray 101 that you've already had, which is great, because when we do this presentation, we're going to take and build off that. So JP's presentation was awesome for that. And my colleague Herman.
Hello, my name is Herman Samerr. I'm from Sesotec in Germany. I'm head of development product inspection equipment. Means we're doing metal detection and X-ray equipment. And I'm really glad to be here in Canada and to have together with Chris. And my task here is I'm the junior partner now. If you're interested in a deep dive into the AI, into neural networks, then you can ask me. And I have also the task to slow down Chris if he is promoting AI too much and brings up a lot of ideas what can be done with AI, and we have to implement it in the research and development department. So
this is where sales promises and engineering delivers, right? And the regulatory people go, wait a second, yes, we want that, but wait.
Okay. And I have to thank Chris because I'm only a director development PI, and he promoted me to the global director development PI. Oh, thank you, Chris, for
Congratulations.
that.
Congratulations. Awesome. All right, so let's dive in. Perfect. So the title is AI Automation, Inspection, and Quality Control. We're going to do a little history lesson. Everybody knows their history, loves their history when it comes to AI. So AI is not anything new. Which is kind of a fun thing, because if you look back into the 1940s, I wasn't around at that point, although the gray beard does match, I think, the one gentleman there. We started with that whole concept of an electronic brain. And this is where, for anybody who studied in engineering, Boolean algebra and or exclusive OR starts to come up into that time frame where we hit that 1970s, the XOR, the exclusive OR, if you remember that from your electronics courses. Into the 1980s is where AI really started to take off, and I just learned recently why. And AI is a concept, and I've heard this, and I've been taught this now, that AI is actually simple math. It's addition and subtraction and a little bit of multiplication. It's very simple. But it's simple math conducted 1 billion times. And so then that's where the complexity comes. So in around the 1980s, for those of you who were hacking computer BBSs by dial-up modem, yelling at your mom, get off the phone, I'm on the internet. Now, those that are laughing and those who aren't are going, the what? That's when computing power really kind of took place. So when we start looking at some of the people that are referenced in behind there, I wanted to put Herman's picture in there, and he said, no, Chris, because where it's going to show is further on in the spectrum. So what is AI? Who here has used AI before? All right, let's actually do a different question. Who hasn't used AI? Have you ever done a CAPTCHA? No, you've never done the I am human, I am not a robot? Okay. All right. Do you text message? Yes? Ever use? No. Oh my gosh. I thought I was a difficult audience member. This is fantastic. All right, so what is AI? Well, The term AI kind of gets thrown out there as a blanket statement. And so when we look at AI, we want to talk about getting the language on the same page here. So artificial intelligence, AI, everybody knows that is AI, right? There's no other definitions for AI in food safety, is there? Avian what? We're going to talk about the artificial intelligence one. When we look at that, we have machine learning and we have deep learning. And often they're all used as the same word. It's kind of like when you do your annual calibration of your metal detector or your x-ray. It's not really a calibration so much as it is a validation. It's validating that it works. When we look at DL, deep learning, it's actually a subfield of machine learning, which in turn is a subfield of AI. Pretty simple and straightforward. I did tell you that AI was just simple math, right? We're all together on this. This is awesome. All right, so AI is a general term that describes that whole kind of genre, if you will, of machine behavior and thinking. And again, machine learning and further development's pretty technical. This is where it gets fun. So I asked the question, who's used AI? So if you take a look at some of these kind of applications, everybody has. It's touched everybody. And so as such, we now take that to the next level and we look at machine inspection and contamination inspection and applying it there as well. Am I going too fast? Perfect. Awesome. All right, so now this is where it gets really fun. Who wants to go into a deep technical dive on AI? All right, Herman. Yes, one person. I like you. So, we can look at AI and we can look at kind of building what that looks like. And when we break it off into boxes, we kind of simplify it. And we can say that, on one level of machine learning, we have what we call supervised learning. Yes, I should probably be supervised. And what supervised learning is when we label or categorize things. So if we show a picture of a dog and a picture of a cat, we label the picture of the dog, we label the picture of the cat, and somebody has to do that. So all of that data needs to be categorized. And I say this one's kind of interesting because when you look at those CAPTCHAs and the pictures, and it says, Google says, hey, choose all of the ones that are traffic lights. Congratulations, you are now supporting Google's algorithms in AI in labeling what a traffic light is, or what a dog is, or what a cat is. And for the 5 of us, my friend at the back and I, when they say choose the cats and we go and purposely choose the dogs, right, just to make sure, they ignore that data anyway, unfortunately. I'm more of an unsupervised learning kind of person, and that's where the data is looked at and correlated, and the machine goes and looks. That's weird. The machine goes and looks at the data and the differences in an image or in a data set on its own, and then makes the determination on, what's different and what's the same, and I'm going to categorize accordingly. And interesting, we had a little bit of a story about this. There was pictures of cats, and the cats were all seen inside, sitting on couches, on laundry that was neatly folded, a square. You put the square on with tape on the floor, and the cat climbs into it. And the pictures of the dogs were all outside, and the dog was playing outside, was jumping in the snow, and then they said, okay, well, now that we've taught the machines learned what cats and dogs are, let's show it of a picture of a cat outside. And I mean, look at that, that's a dog. And what was realized was the AI didn't actually learn cat and dog, it learned inside and outside. And so some of the challenges to unsupervised learning is what is actually being learned. And then there's that whole reinforcement learning, and that's where a machine learns from its own experiences. It learns from failures and then corrects itself, and then learns from a failure and then corrects itself. And then we go into the real fun stuff is where you start getting into the neural networks and deep learning. Questions so far? Go a little bit faster.
200 slides.
He was supposed to slow me down. Okay. All right, so what is AI? Everybody listen to what AI is. So what AI is okay, just kidding. ChatGPT, anybody here use And then when you created the image, did it have 6 fingers or 5? You seen that? Depends on what you want, right? There's actually a Norman Rockwell painting that was on a New York Times, and it's a famous one because the hand placement of the person leaning over, I believe it was AI generated. Yeah, there's a banana one. Yeah, there you go, an artistic. So for those who read Spanish, please don't correct me, but what this says is, hey, ChatGPT, please create me a presentation for the Food Regulatory Summit in Toronto and make sure that you include a picture of the first dog on the moon. And so I got the picture of the first dog on the moon, and this is the presentation. Okay, so not really. But that is an example of AI, is where you can ask questions and then the AI system is going to formulate or compile an answer. Anybody ever heard about the accuracy level of ChatGPT? Yeah, the professors at the university I'm going to right now have. They said, Chris, that was 80% AI. Okay. So when we talk about that accuracy of AI, right, and we talked about that whole neural network, what's a cat, what's a dog, right? On the CAPTCHA, I loved this image because when I looked at this image and you say, okay, obviously they want me to choose the cats. But what would another acceptable answer be? Does that cat look happy? Does that cat look like it's going to take over the world? Now, for those who know Pinky and the Brain, we've got the brain, and then smack dab in the middle, we got Pinky, right? And so, again, that interpretation of what is, and that's where some of the challenges with AI start to show. All right, biology. I know that there's a lot of scientists in this room and in the regulatory world, and so we are going to go into a deep dive on the way the human brain works. No, we're not. But we are going to talk about the mathematical algorithms and the simplicity behind them, and that it's really just ones and zeros that start to build into the complexity of it. So what we're really doing when we talk about AI is we're taking the way the brain works, the way we know or believe the brain works, we're trying to put it into a mathematical equation and do that math and that reasoning. This is an awesome picture. And so this shows the complexity of the math. And so if we take a look on the left-hand side, we've got the inputs. So the inputs are pretty straightforward, single pieces of data. We then take those pieces of data and we combine them all into one equation. And it's a simple equation. And instead of just doing that once, twice, 3 times, 100 times, we do that 30 billion times. And that's where the power of AI, and anybody who's doing any research or reading on the power requirements on these AI data centers and the processing power and all of that kind of stuff, this is why, because all those calculations are being done as quickly as possible and continuously. So we take that information, we do the math on it, it's really simple, it's really straightforward. Once all that math is done, then we get a bunch of outputs. We say, okay, hey, perfect, here's the answers. And that's the easy part. And then as Herman mentioned to me previously, he said, that's the easy part, the hard part is going back the other way. And so we're not going to dive into that. But that's simplistic AI. Everybody understands AI now, professionals? No? Okay, we'll have more conversations after this. So what does Sesotec do with AIs? Well, Sesotec's a manufacturer of metal detectors and x-rays. So within AI, what we use AI for is with our metal detectors as an example, where we've got a multi-simultaneous metal detector. Without AI, we learn the product, we teach the product, we run the product. And it's standard software, and we get the digital fingerprint, we get that product effect going through the metal detector, we know what that looks like, and then we look for deviations or we look for the impact on that inductive field. Anything outside of that bubble, that theoretical bubble, we say, hey, that must be contamination. But what we do know is that products actually have a more specific set of characteristics. And that's where we start using AI, what we call think. So if you think about it, we can now look at the product effect. And that product effect has all those main big bubbles that are creating those U-shapes. That's the actual product effect. And then anything that was within that big bubble originally that isn't in those little bubbles, that must have been contamination. So we're able to dive in much, much deeper on the size of contamination and the reliability on that. And so then that's the sensitivity. And then also, getting those false rejects, because I know every time a product goes into the reject box, you got to pull it out, rerun it, rework it, damage, throw it out, all depending on the process that you've got. So it's a pretty easy process that we have. I'd invite everybody to come by our table. We've got a setup where you can press all the buttons yourself, and we can teach you to be a think expert and user in under 48.5 seconds, or pretty close to. So the way that it works is we take models. So we start off with our original model, and then we build an AI model, and we add another AI model, and we add another AI model, and another AI model. And once we have those 5 AI models running with the original model, we were able to start that machine learning and keep that process of learning going. And so when we have it set for dynamic tracking, the machine's consistently learning. And we say, okay, it's learning good products because it meets the criteria, but if it's drifting slightly, we want to be able to accommodate for that. So when you're talking about food that's coming out that's frozen, or is moisture level changes, things like that. And then what we do is we say, you know what, let's make sure that AI only operates within a certain set of limits, because we don't want it to just keep adjusting itself so much that we're no longer meeting our compliance standard with whatever our wand sizes are. And so we've got a way to tie all that together and make sure that we're not getting outside of that non-compliance window. All right, moving through. So that's kind of the evaluation. We can skip through that pretty quick. If you want a copy of this, I think it's on the app as well. Think with RFID tags. So again, using our think, we're able to identify that there's an RFID tag inside the box. And when we realize that there's an RFID tag inside the box, we can ignore that signal and still make sure that we're looking for the metal contamination. So if you do have product where you're starting to use RFID tags for tracking purposes, great way to make sure that that doesn't affect the performance. Quick sensitivity comparison. Again, go onto the app. You can take a look and see how much better AI is making the size and contamination. The really cool thing is on X-rays. And so taking this technology and applying AI to X-ray and image analysis is something that's very cool. And it's been something that, since I started with Sesotec, has been, we've developed and has been implementing, and this is awesome, leading the edge. We talked about this earlier. Everybody remembers the simple math 1 billion times over? Awesome. So when we take that and we apply that to an image and the data that we're collecting from the image, when we get our image, what we can now do is auto-encode. So we encode that image, and then we decode it and recode it, and then we do an anomaly comparison. So when we're looking at what good images look like, and we've got that, this is what a good image is, we can now say when a bad image comes through, when we decode and recode, we go, wait a second, something's really wrong here. And that something that's really wrong must be contamination. And then we're able to really get much better on detecting things that a normal grayscale evaluation wouldn't be able to do. Right, so again, it's that autoencoder-based anomaly localization. Some examples of some of the contaminations that we were able to get. Anybody who's eaten a chicken breast before and bitten into a wishbone, congratulations, you get your wish. No? Okay. Some other applications for AI, when we start looking at the blue zip ties that everybody loves using because they're metal detectable, but in an X-ray machine, they're not necessarily as detectable. But when we start applying some AI algorithms to it, now with the anomaly, we can start to go, oh, okay, we can see these things. We've got, I thought that was a meatball sub at first. It's actually a baguette that's filled with cream and deliciousness goodness. And I know myself personally, I would take the top of the baguettes, not the middle baguette, or broken product. So there's just, again, just some of the other applications. So when we start talking about what comes next in AI applications, this is where Herman is probably going to reach out and either push me off or hit me with a probe. Machine usage, predictive maintenance. And I know this isn't the right audience when we start talking about machine failures. However, I think you probably do care about it a little bit because you want your machines to be working. So when we look at a reject system and the life cycle of a reject system, if we look at operating hours of a piece of equipment, if we look at the source, the X-ray source, ours is on the bottom and detectors on top, and if you know that the source is starting to wear, that signal strength drops from that top line, which was the original. Oh, that's my notice. I got to go. Keep going faster. And so the line is where we're at today, and that's the deviation. We can say, oh, the source is starting to wear out. And all of this information is on the machine. You just got to go looking for it. But imagine with me. Now this, Herman, please don't listen. Imagine if we could take all that information and put it together into a predictive maintenance system that was using AI to track not only the power cycling, maybe it's tracking the amount of current that's being drawn from the machine, if you're getting brownouts and how that's going to affect the performance of the machine. If we get all of this data and we put it all together, we can now tell you, hey, your machine's going to fail in about 7.5 days. You may want to look at something, right? Did I do okay? All right. Now, I'm going to quote someone here. I'm going to quote Sarah from Trace Gains. And I loved what she said this morning, so much so that I wrote it down. She said, the more processes you can automate, the less chance of mistakes. And so one of the cool things that Sesotec is also doing and working on, and we talked about this for those who were at the Food Safety Summit back in April. That was the first time I ever heard Sonny speak, and I love that Sonny speaks to himself in the third person. I really wanted to do that, and now I can't because Sonny does it. But this was really hit home with me because those hourly audit checks, what we believe is let's automate that. Let's make that where the system is telling the operators and the QA to do this audit check. Not only is it going to tell them to do it, it's going to step them through it. Use this wand, now this wand, now this wand. Do it the 3 times, perfect. Now, don't worry about writing it down because we've written it down with signal strength, with all of the extra data that you want, and we're going to store it on the machine, and we're going to make sure that you sign it so we know that somebody actually did it. And they sign it, and now a QA person, a quality and auditor can come along and have that information on a USB stick. They can upload it to their server. They can track it and start doing some correlation stuff with it. And then tying in our compliance package. And that's something that we do a little bit different. So we're coming up on the 2-minute mark. Oh my gosh, the timing is almost perfect. It's like we rehearsed this. We did.
Say for me, because Chris explained everything perfect.
Oh, geez. ChatGPT. Sorry, that slide, I didn't mean to put it there. Oh my gosh, look at this. There's a conclusion. It's 50 words. Written completely by myself. Well, I asked the question by myself. So I just like to say thank you very much. I know I've scanned a couple of badges, and I think I'm winning. I'm just going to put that out there. If you do have your cameras on you, by all means, please scan if you want to avoid talking to me, or if you do want to talk to me, come and scan. But we'd love to have more of a discussion with you over at our table. So thank you very much.
Thank you. We have 2 minutes for questions. I just want to say thank you so much, Chris and Herman. This is very, very relevant. The reason why is AI is evolving. And if you are connected to plants, production, everything is becoming AI for efficiencies and all the things Chris mentioned. For example, vision systems, X-ray, there's a lot. And where can we translate this into regulatory? Not to take anything away from your presentation, but it's just the scope of this is going to be everywhere, and you have to be part of this. You have to understand it and be aware of it. So I think it's going so fast, it's becoming more engineering focused. How do we ensure we have all the different cultures we talk about, and how you incorporate AI into translating into the culture we want for food safety, regulatory, and all the good things we need to support. Questions for Chris?
Ask a question, win a prize.
Well, in the meantime, I'll ask one very quickly. AI has been funded by governments. A lot of funding out there. So please take this back, look it up. OMAFRA, national level from the federal government, $2-3 billion. I don't quote me on the amount, but there's lots of money available for funding and an opportunity to, Denon?
Hi, Dinesh from Coca-Cola. I wanted to know your experience about using AI for regulatory compliance. So if there is any case studies you have seen whether using AI for regulatory compliance as the regulatory bodies update their websites, and how can you use that information to make sure you are compliant, and also claims development. Is there any case studies or use cases for using AI for claims development? Thank you.
So from our perspective, our application to AI has really been focused around contamination detection. However, what I would say to you is I'd be more than happy to do a little bit of a further dive into that. I'm doing a doctorate program right now, and so using AI to do research. Don't use ChatGPT. For anybody out there who is looking to gather information quickly, use Consensus AI. Consensus AI uses peer-reviewed articles, and the information that you'll get from there is, I'll say it's pre-vetted, that it's real. And it will also give you all of the citations, which is why I kind of jokingly put the citation of ChatGPT on the thing. So we haven't actually done any major on that, but I'd be happy to search with you and for you to put together some of that information, for sure.
There's a lot of regulatory things happening out there. Packaging, for example, there's AI to scan your packaging. It learns the words, different languages. I've looked at a few systems right now. It's available. It's amazing. You scan your packaging. You know that Word document you send to marketing? It will scan both, compare it, and it will give you the results as to highlighting where you have regulatory risk and discrepancies. So there's a lot of tools out there, systems out there where you can do aioli. They talk about you have a checklist, you enter the checklist into, it uses voice recognition, and it learns your business, it learns your terminology. So for doing a pre-op, you have 20 plants, you do pre-ops every day. So that's an example how you can use or QA checks, regulatory checks. It's all developing, so there's a lot of stuff happening out there, so brace yourself, be ready, and
be cautious with the tools that you're using, though.
Yes.
Because it will, again, depending on the tool that you're using, it will make up information. So run your Boolean searches in different ways, and then do your cross comparisons.
So
There's
Chris,
a question here, real quick. One more question.
one
One more
more?
question.
Okay.
He was waiting so patiently.
So if I have an existing metal detector or X-ray machine, and I just want to change his brain and put an AI brain, is that possible, or is that something that you have tried?
So I would say within a Sesotec machine, eventually there could be some possibility there, but for us to take our AI and throw it onto another machine, no. No.
very unique.
Yeah, that's a uniqueness. The only other thing I do want to say is having this thing on, it really, and getting mic'd up, thanks to the team back there, I really felt like Taylor Swift coming up here. And so I know you're not Swifties.
No.
I know you're not Swifties, but you're foodies, right? Right.
Chris, thank you for simplifying this whole AI terminology, Herman. Thank you so much.